All right, so last class today, and I do have some stuff to cover in at least the first half, and then I'll talk about your exam for sure. I will try to give you, I will just tell you what I know for now. You can definitely feel free to ask me questions related to the exam as well. We'll talk about it, and let's just see what we got. Okay, let's go over one by one. Right, so just don't forget your lab number 5. The last day for you to submit will be next Tuesday by the midnight. Okay, just make sure you submit in time. And also don't forget about the required background study on abstract classes and interfaces, right? You got all the materials there already for you. I just released more like a review session survey. So don't worry about if I mention like a makeup class, it's a typo, right? There's no makeup class, right? Definitely not, just a review session in person. If you're interested, just indicate what time and what day that might work for you. I'll choose a time that hopefully work for the majority of people who responded. We'll see. Okay, it's really creative for you. And then I'm going to release the PDF exam guide very soon, but that one there is going to be very similar to what I'm going to discuss today about the exam info, but some more details. I'll also give you guys some example questions to try it out. These might be on the easiest side for the exam. So your safest bet is to really go over all the cover materials for the course. We cover quite a bit in this course. I will also try to wrap up the course also after the final few topics I want to cover today. Okay? And any questions for me? Okay. So let's do a very quick recap. Especially, I just want to talk about this part over here. Hopefully you guys get a chance to review. If you know, you definitely want to catch up, okay, on this part here. I want to start with here, but of course, for the string problems about how to calculate palindrome, how to calculate reverse, how to calculate the occurrences of, they are following a very similar pattern. I'll let you really try to trace and also play with the Java code. That's something we discussed quite thoroughly in the class. And what I'm going to recap over here is here. Okay, so whenever you want to run recursion on an array, we're going to do 2 examples together just to make sure you feel comfortable about the basics. I'll also give you some assigned reading that's required, also for the exam. You do have enough time to really get it done. Okay, right, so whenever you want to call recursion on some array, for example, integer array, so rather than trying to keep creating subarray, which is going to be running lots of loop and also waste of time and also spaces, we said that it's not the way to go. What we're going to have is something like this. Let's just talk about principle very quickly, which might seem very abstract, but I'm going to do tracing together, on some concrete example today. What we do instead is we're going to have still array as the input, but now we specified one pair of integers from and to. You might find some other problems where it might be sufficient just to specify one single integer about the index that you're looking at the moment. But I'll just make it general. You can have from and to. You're really specifying some interval of the indices you're looking at in the one and single array. We're not creating any subarray as we try to make recursive call. So there are typically 2 base cases. Okay? When from is exactly equal to 2, for example, 2. That means we're only focusing on only index 2, only over here. You can think about it's more like a subarray of size 1. When you got this special case over here, when from is strictly larger than 2, for example, you say go from 3 to 2, that's essentially an empty interval, meaning that it's like an empty subarray. In which case, you just got to think about, if I got empty subarray, what should I handle in that base case? We'll see example very soon. And the else part here will just be the recursive case. So here, I'm still trying to call A here, right? I'm not creating anything new, call by value, right? So we actually have been using call by value in quite a few occasions in different contexts. And then here, I'm just saying from plus 1. So let's say if I start with this particular range, from and to, and when I say from plus 1, I'm saying that I don't want to look at the first element anymore. From plus 1. Is going to be starting from the next element, next index, all the way to the end, right? So I'm short and narrowing down the interval I'm trying to look at. It's a very common pattern you will see in the recursion problem, all right? So that's the part you want to maybe catch up if you haven't done so, right? But I think that this recap might just be sufficient for you to follow through the example we're going to talk about today. All right, so that one just a little bit more example, right? You're going to see that when we trace the code for recursion on the array, we're going to pass the same array reference throughout all the recursive call. And we're just going to play with how these 2 indices or these 2 numbers are going to change. You can see we go from 0 to 1, 1 to 2, and when we go to 2, that means we only look at this range of the index, which is only one element. In that case, it's a base case. All right? Any question about this, just conceptually? We're going to do examples. So this is something you may want to get familiar with for the exam, for sure. All right? But let's do example. Okay? And let's now talk about the first problem here. Okay, if you see the slides, it will be slide number 21. Okay? All positive. This, again, this might be something you already solved in 1022, right, in the first year. You can definitely use a loop, but let's try to solve that recursively. Okay? Given an array of integers, we want to see if all the numbers there are positive. So here, the array, we just assume that it's not null. You cannot have any null reference to the input. However, the array might be of length 0, 1, 2, 3, etc. So it could be empty. So you can think about array of length 0 and 1 could be some base cases for you. I would say the most important base case or case for us to determine is, what if the input array is empty? Right, over here. I'm asking basically, are all the numbers in the empty array positive? Should it be true or false? Let me say it again. Okay? This method here is going to take some input array, always. And we assume that the array here is not null, but it might be empty. So now I'm basically asking, given an empty array storing no elements, are all the elements in the array, which is empty, positive? And we should determine whether we should return true or false. This might be something you can handle maybe back in the first year. Maybe you kind of specify the right answer, but you didn't know why. There's a logical reason behind. I can explain also briefly to you guys. But should I return true or false? Let's say there's an empty array. Daniel? True. That's correct answer, but do you have any explanation for that?
My reasoning is there's no negative that we see. So.
Oh, that's pretty good. Okay, I would say, yeah, you're pretty spot on that justification. Okay. Okay, let's just talk about this one here. Okay. So this one here is what we usually call a universal property check. Okay, so are all the numbers. So this is something called universal property. Given some collection, in this case, it's an array. We want to ask some universal property. Are all the elements in this given collection satisfy certain property? In this case, the property is the element positive? Okay. And for those of you who took maybe 1019, you learned about some practical logic. Let me mention that quickly. Okay. This logic alone, like symbols, is not covering the exam, but I want to explain the concept. Okay. See how much you can absorb. So this symbol here means for all, right? You may have seen that if you took a logic course before. We say for every x in certain universe of disclosure, some collection, okay? And then we want some property to be satisfied for x, all right? But in this case, we got some special collection. In this case, x is actually in some empty array, so like an empty set. Basically, there's no such x in the empty set. We can actually check, right? Now, the property here, what we're given, for example, is about whether or not x is larger than 0. Right? Property here, in general, can be anything, as long as you can evaluate true or false. Okay? So it turns out, whenever you have any universal property check, and the collection is simply empty, that would be equivalent to, as Daniel said, true. Okay? We wouldn't go deep into the logical reasoning for that, but the way you can think about it is, as long as you cannot find any violation, like a witness, to prove that the property is not true, then it's got to be true. Okay, so let me write it down. So the reasoning behind is, there is no witness to show property violation. So in this case, I cannot really give you any witness in the empty set, in the empty array, that's going to be not positive. I just cannot. So you got to say, you satisfy the property. On the other hand, one of the exercises I put on the slides. So another property of different flavor is something called existential property. I'll mention that as well. So if I say, you may also have seen this symbol before, there exists some x, again, in some collection, and then you satisfy the property. So this will be, in our case, will be given some empty array. Is there some number that's positive? This one might be easier to think. Can you give me a number that's positive? Apparently you cannot. Then there's nothing in the empty array. So this one here will just be false. Okay, so this one here will be, so there is no witness to show the property being satisfaction. Of course, I'm just kind of trying to show to you the logical foundation for determining these two cases. But in practice, you may just want to remember that. But I wouldn't recommend. Just try to understand why we're returning true in one case, but false in the other case. Okay. Any questions about this? Good. Okay. And then for other cases to be quite straightforward. Okay. Oh, actually, you know what? I can go over here. Okay. So for this case, this one here, empty array, will just give us true. You cannot find any negative. And the only element in this array here is 4, which is positive. So this should also be true. All right. And this one here, all the elements there are positive. So that should be true. And this one here, I can find some witness of violation. So that means overall it's going to be false. Okay, very straightforward. Now, how do we solve this problem here recursively? It's going to be very similar to how we handle the reversal of string. Very similar. Okay. So let's talk about just one of them. Okay. Let's say we got this array here. Okay. When I say all positive, all pos, and then I pass the array A, let me just put it down here. I got 4, 7, 3, and 9. Okay, that's what I want to know. And then let's say we're going to do call by value for the array. I don't want to create any subarray during the recursive call. So I'm actually going to go from the beginning until the end of the array to begin with. So this will be 0, 1, 2, and 3 indices, right? So I'm going to say I want to go from 0 to 3 in the beginning. You can think about this more like an initial call. I want to scan through the entire array. And now, this is not a base case because the array is too long for me to compute something right away. So what I do instead is very similar to how we split the string for reversal. So what I will do is I'm going to say right here. So let's say take the head and also take the tail. All right? Head and tail. I'm going to just look at the head. If the head is positive, that means it's still possible for the entire thing to be positive, depending on whether the rest of the array is positive, right? If this is already negative, there's no way the whole array has all positive, right? That's kind of the logic. Very similar to also palindrome. So I'm going to do just one step, and they'll do the detail tracing a little bit later. Think about this one here is going to be all positive. Oh, sorry. Let me just do one thing here. First of all, we look at the head, which will be the array A at index 0. That one there should be larger than 0. In this case, we're checking if 4 is larger than 0. Yes, it is. So that will be true. Okay? And then we're going to, again, make use of the short circuit evaluation. Given that the first element is already positive, there's a chance the whole thing might contain all positive. So I'm going to make a recursive call. So all positive over here. Okay. So over here, I'm just still going to pass just A over here, just the reference, still just A. I'm not creating any subarray. But now how do I say, I don't really need to look at this element anymore. It's already handled. I'm going to say, now look at from index 1 to index 3. Okay. So, or think about here, we got this is from, and this is to, right? So think about this is from, this is to. I used to look at from to 2, but now I can look at from plus 1 to 2 right here, right? So what I will do is I'm going to say from plus 1 and then 2. So you can think about this one here is really specifying sub-range right here. And then recursively, I'm just going to look at the head and also the rest of the array and so on. You can think about we're just going to keep increasing the from index over here, all the way to maybe when it becomes 3, 3 and 3 will be a base case to handle. That's for later. Okay? Okay, so far? Okay. Hello? Okay. Okay, let's now move on. Let's look at the Java code and see how we can see the correspondence. Okay. So there will be something important for you to see. Okay. So you can see here we got two methods over here. Okay. So we got method number 1 is called all positive. And this is a pattern you will also see in the many examples I kind of assigned to you to look at. Okay. All positive. Another one here is called all positive helper. Right here. Okay. And also notice that the all positive, typically this will be a public method, typically. And the helper method here is going to be private. Okay. The rationale is for any external user to use your method, they should not worry about giving you the range of indices to look at. They only need to give you the reference of the array. Okay. So think about this one here. This is the public version for external user to call. So this is the version for external user to call. Whenever external user want to call your method, they only have to supply the array reference only. They don't really have to worry about giving the from and to. That's something you can do as a programmer, as a routine. Okay? Or you can decide some special interval if necessary. And inside the public method here, you can see we simply say return. And this one here we call the private method here, the public. And this is the one that's recursive. Because you can see all positive helper and also calling itself. Okay, so let me just recap very quickly. This public method here is not recursive. However, it's calling a helper method that's private and it calls itself. So the private method itself is recursive. It's a very common pattern to really program recursion. Whenever you want to give something for the external user to use, you try to keep the parameter number as minimum as possible. And then inside your own class, you can create some private recursive helper to really give a little bit more information. In this case, the indices from and to. Okay. Okay, let's move a little bit further. And then I can look at a from and to over here. From and to, right? So these two, to begin with, it will be 0 and a.length minus 1. So we can think about, to begin with, so that means we intend. Okay, so this one here, from 0 to a.length minus 1 will be the last valid index. So that means we attempt to scan the entire array to begin with, right? From 0 all the way to the length minus 1, the last index. Okay. And now we are within the context of from and to. All right. Let's see where we are right now. If you think about, we're given the array right here. So we got the array A over here. And then in the beginning, we got 0 and a.length minus 1. Okay, we got 0 and also a.length minus 1. You can think about the first index and also the last index. So our intention is we want to scan through the entire array right here. Okay, we start with this. Okay. Later on, we're going to see how we can split this array over here between two parts. One part we can handle right away. The other part we have to somehow handle recursively. Okay. Let's look at the if then else. Okay. So here we got two base cases, which are the typical ones. So we got when from larger than 2, so that we refer to empty range. In that case, just return true. You cannot find any violation, right? That's not positive. Base case number 2, when you got from equals 2, that means you only look at one element in the array. For example, it could be a single element right here. Could be, right? Also, In that case, you just look at whether or not the element there is larger than 0. Okay? The final one here, right here. This is the recursive case. Okay? What that one says is, I'm first of all going to look at A at from index larger than 0. Okay? This one here, you can think about this one here. I want to look at A at index from. Is it larger than 0? If it is not, the entire array cannot be all positive. This is just one violation we just found. If it is positive, then we have to bother to look at the rest of the array, or the tail. All right? Let's see how we can handle that. So this one here, ampersand, ampersand. Okay? Now, how do we specify this part here as a subarray? Okay? Just this part. Except for the first element, except for the head. So that one there is exactly what you saw over here. You can see we got still the A, right? Still the same, call by value. We got from plus 1, and also we got 2. Okay? 2 remains to be A dot length minus 1. That one doesn't change. But from plus 1 is basically going to be 0 plus 1. Right? So it's going to start from here and then go all the way to over here. Okay? So let's now visualize it. So it's going to be just this part here, the orange. Okay, I'll try to make it more explicit for you. But you can think about just right here, right? The tail of the array, the orange part. So that one there, we're going to make a recursive call. And we are still calling all positive. And then we are still passing the array A, right? The same reference. And then, rather than used to be from and to, it's now going to be from plus 1 and also 2, right? You can think about the orange part here is really A at elements at indices from plus 1 all the way to 2. So that's the interval. Okay. Questions about Java code? Yes, please.
This is just a general question. Is recursion exclusive to Java, or is it used in other programming?
Very good question. Latter. So recursion is not specific to Java. So any programming language you're going to ever program, maybe it could be Pascal, could be Fortran, I mean the old days, right? Or maybe the most up-to-date language, maybe R, Python, they all support recursion, yes. Put it this way, as long as your programming language can support function call or method call, then it definitely can have recursion, yes. Yeah. But you know, since for our curriculum in EECS, we mostly try to use a Java language as a tool to teach. So I think whatever concept you learn in this course, in 2101 or even in 3101, you can always adapt it to other programming language. Yeah, definitely don't restrict yourself only to Java. Yeah. All right, let's now do one tracing together. Okay. So I got actually many clean pages over here for you to take a look. Let's do one of them. Okay. And then just make sure you understand, okay? This one's easy. You talk about base case, right? Let's do the harder one just to help you. Okay, this one here, okay? Let's say the input here is 5, 3, minus 2, and 9. We know that the ultimate result should be false, right? Should be. But let's see exactly how we can get there. Let's start with the public method call, which will be all positive right here. Okay, and we're calling A. So you can think about, we say all positive, and then call the A. A is exactly this array over here. Right, we'll start with that. And in turn, that one there is going to call the recursive helper method. And let me use pink. So this will be the recursive helper method right here. Okay, we pass the reference call by value, and then we go from 0 to A dot length minus 1. Okay, so here we got exactly here, right? You can see here we got 1, 2, 3, 4. So 4 minus 1 is going to give us 3, right? So if you like, we can also annotate very quickly about the indices. The indices is going to be 0, 1, 2, and 3. So we go from 0 to 3. Okay, we'll start with that. No recursion just happened just yet. Okay, I kind of already draw the tree right here already for us. But I would say when you try to trace the code yourself, try to draw the tree along the way. I think that'll be a little bit better. Okay. All right, let's now step into this is all positive helper right here. All right. So what we do is we're gonna first of all check to see whether from is larger than 2. So we got from and 2. So 0 larger than 3, false. We don't go there. Okay. So we got 0 and 3 to start with. Right. That's the first call. And then we check to see whether or not 0 and 3 are the same. Also not the same. Okay. So we bypass the both base cases. So that means we're gonna make a recursive call. How do we make it? It's going to be right here. A at from larger than 0. From is 0. So that's why you see A at index 0 larger than 0. A at index 0 is 5. So 5 larger than 0, which we know is true. And notice that we actually got the ampersand. Short circuit evaluation. Since we know this part here is already true, we should bother to go ahead. So far so good? Okay. Because the first element there, index 0, is actually larger than 0, positive, so there's a chance the rest of the array might be all positive. Not necessarily, but there's a chance. Okay. And then we make this recursive call. Okay, that one there, I'm going to use a different color. Let's say we're going to do right here, orange. Okay. So that one there, we're still passing the same reference of A, but now it's going to be from plus 1. So it's going to be 0 plus 1, so that'll be 1, and also 3, right? So that's why you see 1 and 3 right here. Okay, so that's a recursive call. Are we okay with so far? Just about changing the indices, right? We're not really creating any new array objects. We're only trying to pass different value, like an integer value as arguments. All right, so let's now make the first recursive call. So this is the first recursive call. Okay, so we're going to go to this method here again. So now we got 1 and 3. So 1 and 3. Okay, so you can easily check both base cases are not the case. 1 larger than 3? No. 1 equals 3? Also no. So we don't go in there. So we have to evaluate this recursive case again, the second time, right? So that one there, now the from is equal to 1, so it's going to be 1. So we got A at index 1 larger than 0. A at index 1 is 3. 3 larger than 0 is true. Okay, so if you think about this one here, it's going to give us true. That means we still actually have to evaluate this recursive call. So it's going to be a second one. All right, just keep going. Okay, let's finish that. So that means we're going to go to the right-hand side right here for another recursive call. And that one there, let me use maybe green. Okay, so that one there, let me put it here. It's going to be another one here. Okay, so that one, we're going to keep the, it's going to be from plus 1 and 2. So from plus 1 and 2. So 1 plus 1 will be 2, and then 3. Okay, so 2 and 3. So now when we do that recursive call here, it's going to be exactly here. Okay, you got 2 and also 3. Okay, again, you can compare. I used to get 0, 3. 0 plus 1, I get 1, 3. And then 1, 3 here. 1 plus 1, I get 2, 3. Right? You can see the from index just keep increasing. Just get closer and closer to the 2 index. Okay, almost there. And then we're going to make the second recursive call. You can think about this one here is the second recursive call. Okay, right here. Okay, that one there, let's now go for that. So now we're going to go for that. So now it will be 2 and 3. So 2 and 3. Okay, you can also double check the 2 base cases also are not satisfied. 2 larger than 3, false. Also 2 equals 3, also false. Right? So none of the base cases will be executed. So let's now go to the recursive case. So now let's make the recursive call right here. And is going to be 2. So A at index 2, larger than 0. Index 2 is minus 2 right here. So that means minus 2 larger than 0, and that one there is going to give us false. And we know that we actually got the %. Short circuit evaluation tells us as soon as you got the left-hand side being false, you don't have to bother with the right-hand side. All right? So that means this part over here is going to be bypassed. Bypassed. Because here is false. So now we're going to return, right? What's going to happen is for this part over here, we actually got just false. Which means this method call here got false. False and true will be false. So this part over here is also going to give us false eventually. And so this part here will be false. True and false is going to be also false. Right? You can see that it's going to get propagated back for the result. So this part here is also going to be false. Okay, so that'll be the ultimate result that's returned to here. Could be a little bit tedious to really trace, but I think that this might be the most complicated one for the example I gave to you. Kind of trace it together. Let me recap the point you want to really notice. When you trace, I think the most valuable thing is to notice how the two indices change. In this case, just the front index change. So we got a public method here. We got the private recursive method being called. Initially, we get the smallest index and the largest index. If the recursive call is applicable, meaning that the left-hand side is true, in that case, we increment the from value by 1. So go from 0 to 1, and then 1 to 2, and then 2 to 3 right here. Right? You only will execute a recursive call if the left-hand side here is actually true. If that's already false, bypassed. Questions? Go ahead.
So we're not creating a new array manually.
We're definitely not. We're not creating a new array.
But we're growing the spec. Is it not a performance issue?
Not really. Okay, good question. Good question. So what Daniel was asking is, so for this pattern here, we are basically using call by value. So all the A here are just referring to the reference of the same array, the same. We don't really create a new array. So what you're asking is, we might still get a stack to trace the method call, like a all positive, all positive, like a factorial. That one there's unavoidable. I wouldn't call it inefficiency. It's just the way computer will handle at the runtime about method call. So nothing wrong with that. Yeah, you want to make sure this. You don't want to create any new array as the byproducts of the recursive call. That's something you want to avoid. Okay. Questions? All good? Okay. Okay, second example, which will be the last. Okay. So for that one there, I would suggest I can talk about the idea. I can leave the tracing to you guys, but I do want to clarify some important concept, which I think you should really know for this course. Okay. Okay, so we are done with this right here. All right, second one, which is very similar to the first one. So that's why I just want to talk about the idea and clarify some terms, and then I will feel safe to actually leave this stuff to you, to take a look yourself. So let's say this, we are still given an array of integers. Now we want to see if they are sorted in a non-descending order, right? You may have seen such description like a non-descending or non-ascending or ascending or descending. There are 4 possible orders you might encounter in your, whenever you talk about data structure or algorithm, right? I would like to clarify this term over here. Even though the example only talk about non-descending, but I would like to make it complete, okay? I want to talk about all the possible terms you might run into. They are not very difficult to really visualize, but let's try to do that, okay? Right here, okay? Let's start with the easy one, all right? These are all the 4 possible things you will encounter, right? In 2101, in 3101, whenever you want to design algorithm or data structure, these are the orders people like to talk about, okay? You might hear something called decreasing or descending. That's pretty easy. You're basically saying when you try to observe the values in the array from left to right, there should be some downtrend like this. Okay, that's what descending or decreasing really mean. Okay, let's talk about some example. I might have 4, 5, 4, 3, 2, 1. Okay, and the important, so here, if I try to take any elements here, any two consecutive elements, I should really see that the earlier elements should be strictly larger than the later elements. Okay, so the trend goes like this. It should be strictly decreasing or descending. If I got A at index I, its neighbor to the right, A at index I plus 1. They should be. So this one here, like here, should be strictly larger than right here. Whenever you have that pattern there for all the elements, then it's descending or decreasing. Symmetrically, there's also something called ascending or increasing right here. Okay, so if I got A at index I, its neighbor A at index I plus 1. In that way, it should really get a strictly smaller. Okay, example. 1, 2, 3, 4, 5. If I look at, for example, right here, right, you can see that index I is like index 2. Index I plus 1 is like index 3. 3 less than 4. Completely the symmetric one, right? Ascending, descending, very easy to understand. That one I wouldn't worry. The confusing part is about the non-descending or non-ascending. Okay, so let's clarify that. That one there, I'll suggest you do a little bit of derivation yourself, just in case you're not really completely used to the term. Okay. Think about the none here and the none here. Of course, it's talking about not. Or, for those of you who learn about logic, negation. Right? Logical negation. Or you can think about like an explanation mark. Right? If you want to think in Java terms, that's okay. All right? Let's see how we can do, let's say, non-descending. Okay? Whenever I say, let's say this array here, I say it's non-descending order. Let's do the derivation. If I say non-descending, that's, by definition, it is not the case. It is descending. You can think about the none here is the not here. All right? And we learned just earlier, descending simply means AI strictly larger than A at index I plus 1. Right? That's descending. So we know that by the equivalent to, not the case, 8 at index I strictly larger than A at index I plus 1. Okay, so far so good? Just apply negation, right? So now I can distribute the negation over larger than, which will be less than or equal to, right? The negation of larger than should be less than or equal to. So that one there would be equivalent to A at index I less than or equal to A at index I plus 1. So whenever you talk about non-descending, it simply means it could be ascending or it could be no change. Okay? This means ascending. And this one here means no change. And you can try the derivation yourself. Maybe for non-ascending, you're following a very similar pattern. Okay? Now, how do we visualize it very quickly? So when we say non-descending, so it can be ascending or it can be the same, right? That's what we have. So let's say we got some number here. Let's say 1, 2, 2, 3, 4. Okay? So you can see here, for these two, they remain the same. They are not ascending. And also for these two, they are actually ascending. Right? As long as it's not descending, we are fine. Okay? So think about here, we can just draw a picture very quickly like this. That's typically the pattern you will see, like that. Okay? So for example, if you go from A at index I to A at index I plus 1, and then you got another Oh, sorry, let me just write a bit better. And A at index I plus 2. Okay, right here. Right? You can see this part here is smaller than. And this part here is just equal to. Either one is okay. As long as you're not ascending, you're fine. Right? And similarly for the next one. Okay? So that one there, for example, it can be 4, 3, 2, 2, and 1. Again, you can see that here we got the same, no change. And here we got descending. As long as it's not ascending, it will be okay. Okay? So that one there, I just finished the diagram. Okay? Like that. So think about this might be A index I plus 1. And this one A at index I plus 2. Okay? You can think about this one here is about descending. And this one here remain the same. Okay? So try to study all these four together. So once you kind of get things clarified in your mind, you're going to be fine. Right? Doesn't matter which one I might ask you, maybe in the exam. Okay? Question about this? Okay? Okay. So let's now go back to that particular question here. So now we talk about non-descending. As long as it's not descending, we are okay. It can be increasing or it could be stay the same, right? So now you can see right away. So let's just see some example, and then I'll talk about idea, show you the Java code, and then we're good. Okay, take maybe 5 minutes, and then we're good. Let's now talk about here. Are the numbers sorted? Again, we are running into the important base case. If the array is empty, can we say empty array is sorted or not sorted? Daniel? Because?
There's no evidence that it's not sorted.
Yeah, I like the explanation. That's actually right. Yeah. So you're basically asking, are all the numbers less than or equal to its neighbor? We cannot find any violation, witness. So, yeah, good. So this will be actually true because no violation can be found. Okay, a single element array is also sorted by definition. You just cannot find any violation, just one by itself. Okay, so the idea goes like this. If I got something like this, it's too long for me to handle right away. What I do is I try to look at maybe just the first two elements. Look at the first two, rather than the first one. Look at this two. This one here, I know that 3 less than or equal to 6 is the case. Now I have a chance that the rest of the array might be sorted. Now be very careful. When I first consider the first two elements, I considered 3 and 6. But now, when I want to make a recursive call, right? Let's say this. I used to have 0, 1, 2, and 3, right? I only compare 0 and 1. But when I want to make a recursive call, should I go from 2 to 3 or something else? That's the question. Let me write it down here. This one is really worth pausing because that's the critical decision we have to make. Once that one's clarified, I can leave the rest to you. Let's say this. So is sorted is the method we want to call. And then we got 3, 6, 6, 7. And then to begin with, we got 0 and also 3. Because we got 0, 1, 2, and 3. And in the beginning, we want to scan through from 0 to 3. So that's the intention, right? To really split it, we want to look at the very first adjacent pair, 3 and 6. So what we do is we say that can be split into some end here. So 8 at index 0 and 1 should be non-descending. Okay. This is something we want to do. And apparently you can see that that's really checking 3 less than or equal to 6. That would be true. So that means we should really go on to the recursive call, right? So now here's a question, critical question. How do we make the recursive call? Of course, I might still say is sorted. And first argument will be A, call by value. But now, what should I put the two numbers over here? Let's make some concrete number. Just in this case, what should be the number I should put?
Initially 1 and then 3.
1 and 3, okay, that could be one choice. Why not 2 and 3? You're suggesting I should put 1 and 3 here, but why not 2 and 3?
Because we have to compare the 1, if 1 is like less than the next number or not.
Yeah, you basically have to compare all the adjacent pairs, right? So we just compare these two. Think about when you want to really compare, you want to compare these two, and also these two, and also these two, right? You really want to compare all the adjacent pairs. So now that I compare 0 and 1, what will be the next one? It should be 1 and 2. So the from here should be 1, okay? Yeah, just be careful about this one here. This is not the way to go, all right? So you're going to put 1 and 3. So that one is really suggesting that, so 1 and 3 over here. So it's going to be 1 and 3. So once we try to execute that recursive call, it's actually going to look at 1 and 2 over here. So that'll be the right way to go, okay? Another one, let me write it down. So this one should be boiled down to basically A0 less than or equal to A1 and A1 less than or equal to A2 and also A2 less than or equal to A3, right? So you can see that you should always start with 0, 1, and 2. Okay, something to keep in mind, all right? All right, if you look at the Java code, exactly what I just said, right? So from plus 1. Okay, so this is something you want to pay attention to, okay? All right, and the base cases and recursive case are just like before, right? So now you can definitely take a look. Okay, and for the tracing, I'll leave them to you. I just got several cases over here. You can look at the tree, especially for this one here, which is supposed to return true. And this one here is supposed to return false, because when you look at these two elements, 6 less than or equal to 5 is going to be false. Short circuit evaluation is going to false. It's going to force the evaluation to stop, right? It's going to return false. Okay, so try to look at the tracing. Question? Daniel, go ahead.
Is recursion useful for counting? Let's say you want to find how many, like if the array contains 3 consecutive.
Oh yeah, for sure. You can think about the occurrences of string method that we actually talked about. Went over before. Exactly the same. Yeah. So recursion is really a very good way to really think about things. To try to make a recursive call. Try to think about recursively, right, when you design a method. Yeah. Okay. Good. All right. So let me just spend about 2 minutes just to wrap up the course. We'll take a short break and we'll talk about exam. Okay. Good. So before that, I just let you guys know there's only one more thing which I think you guys will have to study. Okay, that one there will really take some time, but it's already got recording there. So this is just another recursion puzzle. It's a very typical one, a very classic one. You may have seen that maybe in your math course, but this one here can be nicely turned into Java. I also got a source code to get available on the lecture site. You can also play with it. It's a very fun puzzle to study and also see how you can think of it recursively. This will be a problem you don't want to really solve using a loop. I'm not too sure how easy it might be. Just not natural to think about iteratively for this problem here. Okay, how can you find it? Okay, you got choices. If you only want to look at the slides, no problem. The slides is there. But if you want to go through with me in some lecture recording, you can just look at under the recursion here. You'll see under required readings, you got Tower of Hanoi, right? You got all the nodes there, and also recording. All right? So do this one before the exam. Okay? You do have time. Just make sure you don't forget. Okay? Okay, let me just spend a few minutes just to wrap up the course, and then we'll take a short break. Okay, all right. All right, let's see the topics we have learned, just some partial lists. It's not like a very detailed. So let's see what we have seen in this course. Okay, procedural programming in Java, we do exceptions and also recursion. Right? Especially recursion is going to be a very nice way to transition to your 2101 next term. Especially you will definitely need recursion to understand many concepts over there. Recursion. All right, data structure. But in this course, we only talk about arrays. But in 2101, the follow-up course, you'll talk about many different things. Linked lists, trees, etc. Okay, so that's something we just focus on for this course. But it will be a good foundation for you. And then OOP a lot, see all the basics in your labs and also the review lecture, aliasing. Okay, inheritance, we definitely spend a lot of time. The design principle, cohesion, single choice principle, expectation, right? Substitution, static dynamic type, polymorphism, dynamic binding, right? And also polymorphic array. That's really something, that's really why we talk about inheritance, to see how you can use it in practice. Okay, also we talk about different exception, like a class cast exception, and also the instance of operator, right? Also overriding. Okay, Eclipse, of course, whatever you learn, whatever skill you pick up from Eclipse, there are many other programming IDE you can also use for different programming language, like IntelliJ, other IDE, I'm not too sure, Visual Studio, they all support similar features, right? It's just the look and feel might be a little bit different. Okay, breakpoint debugger, that should be your friend, right, to really develop something serious. Also unit testing, regression testing. Okay, so this is not required, completely optional. So for those of you who might just want to see what's another natural extension to inheritance is something called Java generics. Again, it's not specific to Java. Any OOP language will support generics. Many Java collection classes actually support generics. So it's actually quite a practical topic for you to go through. Not covering the exam, but for those of you who may want to study that, you can just go through this link here. You can have some nice introduction to the topic. All right, I'll suggest two things for those of you who might be wondering, what should I do beyond this course to sharpen my skill? So this is a classic textbook in algorithm. I think many of your professors might choose this one as a main text. So that one there has a very good collection of algorithm and with a pseudocode, not really Java, but pseudocode. So what I would suggest is if you really want to get one copy for yourself, really worth having it in your shelf. You can try to go over algorithm by algorithm and try to go over the math and also try to understand the pseudocode and then turn them into Java. This will be a very good way to see how you can program. And once you have done your implementation, you can now try to write some JUnit test cases to really specify what should be the input and output expectation for the method. That'll be one. Another one is more about software design. This might be something your instructor in 3311 will recommend. So now that we learned about inheritance, if you want to get more serious about getting some practical application to be done, you want to look at something called design patterns. So these are all the recurring problem scenarios people recognize in the industry. So they talk about how you can solve them one by one using inheritance. In your lab number 4, I never mentioned the term. There is actually a design pattern there for the channel video there. It's called observer pattern. You didn't notice that? You don't need to. But pattern there is just a very nice way to see different scenario and to assess about how you can use inheritance to solve them. Right? Similar exercise, right? All right. Apart from that, yeah, all the best. And then I'll see you at least once more, maybe in the review session, right? But if I see you next semester, maybe in 2101, I'll see you there. If no, maybe I'll see you in some future course. All right? Sounds good. Why don't we take a short break and I'll talk about your exam.